Hi, in this video we are going to talk about the basic sorting algorithm, the so-called bubble sort. So let's get started. The sorting algorithm repeatedly steps through the list to be sorted, compares each pair of adjacent items, and swaps them if they are in the wrong order. It is too slow and impractical for most problems, even when compared to insertion sort. We are going to talk about insertion sort too, so it will be clear. So bubble sort has worst case and average complexity both O and times n, so it has a quadratic time complexity, and we are going to talk about much more efficient, much effective sorting algorithms that have a running time of n log n or do n log n, which is much more better. So bubble sort is not a practical sorting algorithm. It will not be efficient in the case of a reverse order collection, for example. We have to iterate through, even if we know that we just have to reverse it. But in computer graphics, it is popular for its capability to detect a very small error, like a swap of just two elements, for example, in almost sorted arrays, and fix it with just linear time complexity, so ordo n. For example, it is used in a polygon filling algorithm where bounding lines are sorted by their x-coordinate at a specific scan line, the line parallel to x-axis, and with the incrementing epsilon their order changes, the elements are swapped only at intersections of the lines. So in these special cases, bubble sort can beat, for example, much more efficient algorithms such as merge sort or quicksort, and we can solve this kind of problem with linear time complexity, which is very efficient. And it's a stable algorithm like insertion sort, which means that if we have two elements that in the right place, then the algorithm is not going to change the index of these elements, so it's going to remain in the same position. Okay, so let me illustrate how it works. For example, we have an arrays of integers 7, 4, 6, -2 and 1, and we want to sort it numerically. So we start at the beginning, and as I said earlier, we keep comparing the adjacent items. So we keep comparing 4 with 7, and we came to the conclusion that 4 is greater than 7 is greater than 4, so we have to swap them. Okay, and we hop to the next two items, the next two adjacent items, and 7 is greater than 6, so we swap them too. Then we compare 7 and -2, and we swap them accordingly, and compare the last two. And in this situation, we compare the number 7 with all other items, so we can come to the conclusion that 7 is the greatest element in our array, so we consider it sorted. And start the algorithm again from the beginning, from the start, and 4 is less than 6, so it is in the right position. 6 is greater than -2, so we have to swap them. 6 is greater than 1, so we have to swap them. And we are not going to compare 6 with 7, because in the previous iteration we came to the conclusion that no elements are greater than 7, so we stopped here and consider the 6 sorted too. Okay, and we keep going until all the elements are in its position. So 4 is greater than 1, so it's here the right position, and we keep comparing -2 with 1. This is the last comparison, and we come to the conclusion that they are in the right place, so we consider both of them sorted. Okay, and -2 sorted. So that's all about bubble sort. It's very easy. Thanks for watching.